Sorry, I am a few minutes late. I was actually on baby duty today. Our nanny did not arrive in time, so I have been playing defense and catch up. So, again, sorry that I'm late, you guys. We are going to get rolling here right now. Let me just see. All right, everybody is here. Again, apologies for the delay. Was wrangling meetings, a baby, no nanny, so we are a little bit behind, but I appreciate everybody's patience. Happy Thanksgiving, and we will just go ahead and jump into it. And I will stick around a little bit after class too to answer some additional questions because I actually don't have any meetings immediately after this today, which is great. So awesome. Thank you guys. Excited everybody's here again. We're starting a few minutes behind, but let's get rolling. So let's start. Go presenter view. Got it. Okay. So today we're covering fats, and this is going to be the last of the three major macronutrients that we're going to be covering. And then tomorrow we're going to be covering alcohol, which is also, or not tomorrow, sorry, 2 weeks from now, because we won't have class next week. We'll be covering alcohol, which is kind of technically the fourth macronutrient, but this is kind of the last of the big three. Okay, so let's talk a little bit about fat types and structure, because I think this is the first place to start. So in nutrition science, in kind of nutrition more broadly speaking, we commonly use the term fats too broadly. It's kind of a colloquial term that we've used, and the actual correct term is lipids. So lipids are a class of compounds, and it includes a wide range of different ones. And fats is actually just one subtype. So like fatty acids, like free fatty acids in our blood, or the fatty acids we consume in our food, is just one type of fat. And so we actually can classify fats as, or lipids, excuse me. So even I make the exchange in my own brain. Um, we break them into structured lipids or structural lipids and storage lipids. So structured lipids are things like steroids, phospholipids, etc., and storage lipids are things like triglycerides and fatty acids. So they're either used for energy storage and metabolism, which is the triglycerides and the fatty acids, or they're used for things like cell membranes, hormones, bile acids, cell signaling, etc. And so it's really important to understand that we have like chemical lipids in our body. We consume chemical lipids, and some of them are used for storage, hormones, etc., and some of them are used for energy and metabolism. So if we go back, steroids are a type of structured lipids, or sterols. They are a class of molecules that support cell membrane integrity. They often serve as the precursors for steroid hormones and vitamin D, and they help form bile salts for fat digestion. Cholesterol is probably the most well-known sterol, so it's cholesterol, and that's found mostly in animal products, while plant sterols are also consumed. So cholesterol is basically the backbone of all of the sex hormones, so testosterone, estrogen, progesterone, etc. It's also the precursor for vitamin D. So your body actually manufactures vitamin D out of cholesterol. And then there's a whole bunch of other things that cholesterol ends up being used for. Now, what's important is uh, these don't actually provide energy. So cholesterol doesn't provide any sort of ATP for your body. I mean, maybe indirectly the carbons get used for it, but specifically, they're not used for energy like fats are. So when you eat an egg, and part of that egg contains like saturated fatty acids and part of it contains cholesterol, the cholesterol you consume doesn't get used for energy, but like the saturated fatty acids can. So there's a difference between the type of fats that you consume and what they're used for. Phospholipids are structural lipids, and they are essential for forming cell membranes. So basically, every cell in your body has a layer of fat around it. They're called phospholipids. Um, and if you guys remember back to like sophomore year of high school biology, phospholipid bilayer. This is basically just the way that your cells are organized to keep water on the outside and on the inside separate, right? Think about it like, this isn't quite accurate in terms of like the chemistry of it, but like when you have a soap bubble and there's water on the outside and there's water on the inside, that's kind of what your cell membranes look like. We actually do eat quite a few phospholipids. They're in egg yolks, they're in organ meats, they're even in things like oats and some seeds. But most of them are actually broken down during digestion. Your body kind of has to rebuild them from the breakdown products of the dietary fats, and then we create them in our body. Okay, so triglycerides. These are the ones that most of us are familiar with. They are the primary form of stored fat in the body. They're made of 3 fatty acids, and they're attached to a glycerol backbone. That piece of information, the glycerol and then the fatty acids, is mostly important for when you are like reading research papers. A lot of times they will use glycerol appearance as a kind of quasi-metric to measure like fat oxidation and fat utilization. So you imagine if you see large amounts of glycerol starting to increase in your blood, what that means is your body is starting to break off the fatty acids and use them because the glycerol is now free and it's floating around in your blood. When the fatty acids are not attached to glycerol, they're called free fatty acids, and these are actually what provide most of the energy for our body, especially in stored form. I know I have this figure in the book, but I think the average human being, and we can just do the math, stores like 100 to 200,000 calories of fatty acids. Like even a relatively lean person. Like let's take a 180-pound person with 10% body fat, so that's 18 pounds. And there's how many grams in a pound? I think there's like 453 or 463. So we'll just go 18 times 450. That's 8,000 times 9 calories per gram. So even like a relatively lean person has about 70 to 80,000 calories stored just of body fat. That's not including intramuscular triglycerides, etc. So if we compare that to like stored glycogen, which is about, what do we say, 1,000 to 2,500 calories, depending on like the person and like how extreme of a number that is, that means we have 50 to 100, 200 times more energy stored as body fat than we do as carbohydrates, which is kind of a wild thing to think about. It's a sort of like, if any of you guys drive like hybrid cars where they have like the 12-volt battery for the electric part, and you can drive like 20 miles on that, but it's like super quick. Like you press the gas and it gives you some get up and go. Sorry, the accelerator, not the gas pedal, because it wouldn't be using gas. But you have like 500 miles of a tank of gasoline. Like that's the difference between like carbohydrate storage and utilization and fat storage and utilization in the human body. Let's see. So we also have different ways of classifying the fatty acids. They are known as saturated fatty acids, monounsaturated fatty acids, and polyunsaturated fatty acids. And all this means is how saturated the carbons are with hydrogens. So saturated fats, every carbon has 2 hydrogens attached to it in the chain, or the one on the end has 3 to make up the 4 bonds, right? Carbon always has 4 bonds. Then we have like monounsaturated fats, which means one of the carbons in this long chain, it can be anywhere from, 10 carbons to 30 carbons. I can't remember the exact number, but some of them get pretty long. Maybe it's a little bit less than 30 or a little bit more. But that means they have a double carbon bond. So they're missing some hydrogens, which means they are unsaturated in one spot. That's monounsaturated. So one unsaturated spot. Then we have polyunsaturated. This means they have more than one. So it can be 2, it can be 3, it can be 4, it can be 5. And where we see this actually matters quite a bit is all of the omega-3s and omega-6s are denoted by they're all polyunsaturated, and whether they're a 3 or a 6 depends on where their first unsaturated point is. So an omega-3 is it's on the third carbon, right? If you go here, the first saturation point, 1, 2, 3, that's an omega-3. If it was an omega-6, the first one would be 1, 2, 3, 4, 5, 6. It would be right here, right? That affects the properties that the fatty acid has. It affects it from like the physical structure. So saturated fats are more solid at room temperature. That's why like coconut oil and butter is solid at room temperature, whereas things like polyunsaturated fats, which are like vegetable oils, are liquid at room temperature. It also affects like how they cook and their smoke points. So the primary sources we have of saturated fats in our diet include animal products, primarily things like beef, pork, butter, cream, cheese, other dairy products. They're also in plant-based sources. So we have things such as coconut oil, palm oil, peanut oil. Those are also very heavy sources of saturated fats. These have been talked about a lot in relation to chronic diseases. We're going to explore that a little bit later. We also talk about it more in depth with specific disease cases in the nutrition and chronic disease chapter, but we will talk about that a little bit here today. A very kind of random fact, but side note, palm oil is becoming one of the largest sources of saturated fats in kind of the Western diet. And there are like entire islands in the like Asian Pacific Ocean that have just been converted to like palm oil farms. Like if you go, it's just everything is palm trees for palm oil. It's really wild. Like I watched a documentary on it, and it was, I mean, there are like tens of thousands of acres of these trees that just get processed because it's cheap. Okay. Then we have mono and polyunsaturated fats. We kind of talked about their chemical structure. These are almost entirely found in plant-based foods. You do get some of them through animal sources, especially like the omega-3s. The long-chain omega-3s are almost entirely found in animal foods, but they're mostly found in plant foods. Monounsaturated fats come primarily from things like avocados, olives, nuts, and then even like lard and goose fat also are high in monounsaturated fats. Polyunsaturated fats, which contain the omega-6s and omega-3s, most of those come from like fatty fish, especially omega-3s. Then we have like walnuts, flax seeds, soybean oil, grapeseed oil, and safflower oil. We'll maybe talk about seed oils later if we have some time today, but I want to just focus primarily on like fats as a concept, and we'll talk about seed oils in a little bit. So one of the things that we know is the omega fatty acids, both omega-3 and omega-6, are essential fats, which means just like essential and non-essential amino acids, our body does not manufacture enough of these essential fats that we have to get them through our diet. And we need different amounts of each. So we need about 1.1 to 1.6 grams of omega-3s per day, and we need about 12 to 17 grams of omega-6s. I want to come back to the ratio thing because that's a big question. I'll talk about that at the end of this slide. So omega-3s come in two forms, and this is actually one of the like small details in nutrition science I think that actually matters to everyday people. So we have short chain omega-3s, which is primarily, it's called alpha linolenic acid. That comes from things like flax seeds, chia seeds, and walnuts. And then you have long chain, which is EPA and DHA, which is eicosapentaenoic acid and docosahexaenoic acid. Those come from mostly fish, right? That's where we get most of our long chain omega-3s in our diet. Now, one of the things we're often sold when we go into the grocery store is like omega-3 rich foods, right? A lot of times you'll see things like flax seeds, chia seeds, etc. But the problem with those is our body has a really poor conversion rate of short chain to long chain. In fact, it's less than 5%. So if you're consuming most of your omega 3s from these short chain fatty acids, you're actually not getting the long chain. And the long chain ones are the ones that are the most important overall for like anti-inflammatory, heart health, all of those things. So make sure if you're not eating a lot of fish in your diet, this is where supplementing with fish oil actually makes sense for a lot of people, especially those people who don't eat a lot of fish and who think that they can get enough just from short chain fatty acids. So the food sources that have the highest amounts of EPA and DHA outside of supplements are things like fatty fish, so mackerel, salmon, sardines, anchovies, tuna, oysters, shellfish like crab, shrimp, things like that. You can also get small amounts from like algae and seaweed. Now, those you really have to consume a lot more. Like if you consume 100 grams of mackerel, you get almost an entire day of omega-3 fatty acids, the long chain ones. But if you were to eat like algae, like spirulina, you would need like 2,000 grams. Like that's a lot. Like that's a lot of spirulina to eat. Okay, so now let's talk about trans fats. So trans fats, how many of you guys used to eat I can't believe it's not butter? That was a staple in our house because for a long time everybody thought that butter was bad and you should consume margarine instead. So trans fats are made primarily, they're primarily a processed fat. They're made through the partial hydrogenation of polyunsaturated fats. So they take these polyunsaturated fats and they just slam a hydrogen into it. And that actually makes them still unsaturated, but it changes their chemical structure. So they're solid at room temperature. They have a longer shelf life. And you can turn like what used to be a liquid into like a spreadable fat, right? So this is what I can't believe it's not butter was, right? It's today it's mostly found in processed foods like baked goods and margarine. I'm a fairly skeptical person, and I think most of the claims about things being quote unquote bad for you are overblown, with the exception of a few things. Like trans fats are actually highly linked to bad health outcomes, especially cardiovascular disease, primarily through altering lipid profiles. So it usually raises LDL, raises triglycerides, and lowers HDL. So it basically puts your lipid profile into a pro-atherogenic profile. So it increases your risk for cardiovascular disease. And the data on this is so compelling that the FDA has actually come out and said these should be limited or not allowed in our food supply. Right? So like you can go look at the FDA rulings on this. These are like you can't really add trans fats into products anymore. And if you do, they have to be below a certain amount. And the amount that you have to consume a day to actually see increased risk is relatively small. It's like 2.5 to 5 grams a day meaningfully increases your cardiovascular risk. So this is one of those things like really try to limit these as much as you can. Now, the nice thing is most food manufacturers are not putting these in their foods. So unless you're going to the store and buying a bunch of like pre-made baked goods, like if you're just eating store-bought muffins and croissants every day, you may be getting a decent amount of these. Or if you're eating like I can't believe it's not butter that's been in your storage pantry for 30 years, like you're probably getting a very minimal amount of these. Yes, Crisco. Although I think Crisco's updated their formula. I'd have to go check. I haven't bought Crisco in probably 20 years, so I'd have to look. Cynthia said, so going back to omega-3s, does that mean that people who don't eat animal products should be getting long-chain omega-3s in supplement form? Definitely. So this is a little bit of a side note. We can talk about this when we get to the supplement chapter in more detail. But individuals who are adopting a strictly vegan or vegetarian diet should be consuming a long-chain omega-3 supplement, probably about 1 gram of EPA and 1 gram of DHA a day. They should also be consuming some choline, vitamin B12. Those are some of the things that you really don't get from plant foods. And we'll talk about those as we get into further chapters. But like as a quick overview, that's kind of where we're at. All right, so now that you know what the types of fats are, let's talk about the function in the body. So it has four major roles. It's involved in energy storage. It provides structure. It is important for hormones, and fat is actually an organ in our body. And we'll talk about that here in a second. Next slide. Okay, so fat is energy storage. Fat's primary role in the body is to serve as a major source of stored energy, especially at rest during low intensity activity. And we talked about this earlier, but if we actually take my example earlier and take it to the average US adult who's about 185 pounds and 30% body fat, they actually have about almost 250,000 calories of energy stored in fat reserves. Like, that's a huge number. So kind of just let that sink into you. It's like, so if you spend 2,000 calories a day, the average person has, like, you could not eat for 100 days and have enough energy to, like, survive. That's kind of a crazy statistic. That's the average person. Okay, the next one is fats also play an important role in structure. So they obviously they build cell membranes, but they also, part of that role is they actually give us the compartmentalization of our body. Like, we wouldn't have organs, we wouldn't have compartments in our body. Like, we wouldn't have our digestive tract, our blood vessels, our organs, any of those things without fats, structural fats, because they allow us to separate water-based environments with like a non-permeable membrane. Beyond that, they also actually provide physical protection. So your heart and your kidneys especially have these layers of fat around them that provide protection from, like, physical impact. They provide insulation, all sorts of things. All right, we talked about this a little bit earlier, but fats are also important for hormones. So obviously from an energy perspective, but when we look at the actual, like, hormones themselves, especially things like testosterone and estrogen, the lipid class of things, especially cholesterol, they are the basis of our hormones. So when you don't have enough cholesterol and fatty acids available, we often see decreases in sex hormones. So this is one of the reasons by which, like, low energy diets, so when you're dieting for a long time, you see reductions in, like, sex hormones. Part of it's just low energy availability, but the other piece is we just don't have enough spare fatty acids to make additional hormones. Okay, so the next thing is fat is an organ. So this is a concept that not a lot of people are familiar with, but we have our skin as an organ. Obviously, our heart, liver, lungs, brain, eyes, kidneys, pancreas, all those things are organs. But we also can consider, like, our adipose tissue as an organ. And that's because, like, by definition, an organ is self-contained, has specific functions, and consists of specialized cells. So I have an entire talk on fat as an organ, and maybe as a bonus one week we'll do that in the group. But fat has some really interesting roles. So we talk about this in a later chapter. We talk about it twice in later chapters, but one of its roles is it acts as a thermostat for body fat, and we call that the adipostat. And it regulates energy balance by producing hormones like leptin, which influence hunger and activity levels. So we'll talk about this in a lot more detail in a later chapter, but your fat tissue, and this holds true in a lot of animals as well, is effectively like your thermostat in your house. So when your fat tissue increases in amount, your body releases more of a hormone called leptin, and that tells your brain to reduce food intake and increase energy expenditure to bring your fat level back down. When your fat level gets too low, you don't have much leptin in your system. That tells your body to eat more food and move less. And so that is one of fat's main function. Now, obviously, that system doesn't work super well in the modern world, and we will talk about that later. But fat definitely has a major role in regulating those things. So that's why we consider fat as an organ. So let's talk about fat digestion. So similar to all of the other macronutrients, so carbohydrates, proteins, and we'll learn alcohol, fat digestion begins in the mouth. And there is a little bit, but not very much enzymatic action. So most of the fat metabolism actually occurs in the stomach, and that's where its first action occurs. So gastric lipase starts to break down fats. That's where it starts to get broken down, although not a lot occurs there. So it's not that most fat digestion occurs there. That's where the first of it occurs there. And then most of it actually occurs in the small intestine. So pancreatic enzymes and bile salts kind of emulsify fats. And so the best way to think about this is, like the best analogy is whenever you, like if you guys ever cooked steak in a pan or cooked something with a lot of oil in a pan, and when you go to clean it afterwards, you put soap in there and you mix that with water, and all those bubbles create a ton of surface area, and it kind of helps emulsify all the fats that are in that pan, and they lift it off. That's effectively what your bile salts do. They basically make like a soapy like environment, so it creates a lot of what we call micelles for easier absorption. Now, sort of like what we learned about in the digestion chapter, fats are actually digested substantially differently than carbohydrates and proteins, and that they don't actually go directly into your bloodstream. They end up going into your lymph system first. They travel through your lymph system, and then they dump out from your subclavian into your bloodstream. I haven't ever looked up exactly why that is. Like, what's the evolutionary purpose for that? I probably need to look into that now that I think about it. But that is how fats are metabolized, and it's much different. Okay, so now let's talk about fat metabolism. So, unlike carbohydrates which go through glycolysis, fats are oxidized almost entirely through the Krebs cycle, with the caveat of some of them can be converted into ketones through a bunch of roundabout ways, through beta oxidation, and then they get converted into ketones, but those eventually then get converted back and they go through the Krebs cycle and the electron transport chain. So we're not going to go into like super in depth about these, but I do want to give you guys just a very brief overview so we can kind of understand primarily the difference between carbohydrate metabolism and fat metabolism, and why carbohydrate metabolism is used for like quick energy production and fat metabolism is used for a little bit slower energy production. Okay, so here is essentially the process of taking the fat that is stored into your body and turning it into energy. So you have to form a molecule called acetyl-CoA from fatty acids, and this occurs in a couple steps. So you take these very long chain fatty acids and you start cutting them up with enzymes, basically chemical scissors, into 2 carbon units. So those little chunks, you basically just cut off 2 carbons at a time. Those then get converted into a chemical called acetyl-CoA. Acetyl-CoA then goes into the Krebs cycle. The Krebs cycle produces a small amount of energy, but its primary role is it produces these other things called NADH and FADH2, which you don't need to know exactly what those are. But then those 2 things go to what is called the electron transport chain. The electron transport chain then just uses a chemical gradient to drive hydrogens, create an electrical gradient, and then make ATP. So you guys don't really need to know all the details of that, but just understand the process by which fat gets converted into ATP is this process. Long chain fatty acid gets cut up, turned into acetyl-CoA. Acetyl-CoA goes into the Krebs cycle, which is like a multi-stage process. It creates some energy, but primarily it creates these secondary molecules. Those secondary molecules go to the electron transport chain, which have to create an electrical gradient, which then makes energy. So that's a 5-step process that involves a bunch of chemical reactions. Whereas glycolysis is, I take a sugar, I split it in half, I get energy. So you can see why, just from like a chemistry standpoint, one of these takes substantially longer to happen. Now, it turns out that when you oxidize fat, you get a lot more energy. You just get it much more slowly. So this is why we have this balance of, hey, if I need energy not as quickly but over a long period of time, it's more efficient to use fat for energy. But if I need something quickly, it's much faster to get that energy from carbohydrates. So the whole, like, we use carbohydrates to fuel high intensity exercise is really a feature of chemistry. Like, it is the only way you can do it quickly. So now let's talk a little bit more about how we store fat from, the fat we consume and it gets stored, or the excess calories we consume and then they get stored as fat. We actually store it in 3 major places. There's a few more than this, but like these are the 3 main ones. Subcutaneous, which is the one under our skin. Visceral, which is inside of our organs. And then intramuscular. So sort of like we store glycogen inside our muscle tissue, we also store fats inside our muscle tissue, so we can use that quickly for energy. You guys are going to learn a lot about why we have that there in the exercise chapter at the very end of the science book, because our body will use the fat in our blood and the fat in our muscle tissue differently based on exercise and like intensity of movement. But those are the 3 places we store it: under our skin, around our organs, and in our muscles. So that means, based on kind of where things are stored in your body, we have different fat cells. We have white fat cells. These are primarily just energy storage cells. So think about these like this is the gas tank in your car. They just store a large amount of triglycerides. They obviously have all the like requisite parts of a cell: a nucleus, the mitochondria, the Golgi apparatus, the ribosomes. They have all those things, but primarily they just are a storage vehicle for fat. Then we have another type. I'm going to switch to brown fat cells first. These are types of cells that actually are used to create heat. So they have a very high amount of mitochondria, and they're just organized differently. So what their primary job is that they burn energy to put off heat and heat your body. These are actually found in very localized areas, primarily in your neck, your spine, your armpits, and your groin. What's really interesting is you can actually use infrared cameras on people to find brown fat spots. It's kind of cool. Then you have beige fat cells, which are a little bit in between. So they have a decent amount of fat storage, and they have a little bit more mitochondria than white fat, but not as much as brown fat. Now, interestingly, it would make sense that, okay, if overweight and obesity is primarily an energy problem, why don't we just increase brown fat so we expend more energy and then we can lose weight? Well, we've actually studied this a lot. We've looked at it in cells, animals. We've even developed drugs in humans. It turns out that, 1, it's not super effective, and 2, the medications or the drugs that actually target this, in order for them to work, they come with major risks and side effects. Like DNP works a little bit on this. It's not brown fat specific, but it basically just causes your mitochondria to burn a bunch more energy the way that brown fat cells do. Okay, so now we're going to switch to dietary fats and weight management. So if you recall, I think most of us here were old enough to have been alive in the 90s. Pretty much the 1990s and the early 2000s were marked by low-fat diets as a primary tool for weight loss. And a lot of times people will say, "Oh, well, that was just silly. We didn't know what we were doing," and it was primarily based on the fact that fats have more energy density, etc. So they should lead to weight loss, and it didn't work. It's a little bit more complicated than that. And there was actually a lot of really interesting research in the 1990s that really gave us insights into, in the modern environment, how do diets with high fat intake impact our overall calorie intake and our ability to control weight. And so if we kind of just ask the question like, okay, what has the media told us, what is versus what is the science and the data told us? The popular views on dietary fat and weight gain have shifted over the decades, but scientific research has consistently provided valuable insights. So in the 90s, there was a bunch of research that looked at high fat versus low fat versus medium fat diets, and they showed that if you just let people free feed and didn't control calories, people who had higher fat diets, which meant like 45 to 50% of calories from fat, usually lead to substantially more calorie intake than people in lower who consume lower fat diets. So this graph on this slide here basically shows the average calorie intake of these people during the study and their weight change. So people who consumed a higher fat diet but didn't really track calories, I mean, they consumed about 650 to 700 calories a day more. So over the course of a week, like that's a pound, right? And that correlated with body weight changes. And so why is this? One of the things they learned during these studies is that the energy density of the food you consume definitely matters. And so people often eat the same volume of food regardless of calorie and fat content. And so since higher fat foods generally tend to be more calorie dense per volume, we usually eat higher calorie intakes total without realizing it. So the very extreme example I give you is like if I give you a bowl of carrots versus a bowl of nuts, you're probably going to eat about the same volume of food, but the bowl of carrots maybe has 100 calories, where the bowl of nuts can have 12, 14, 1500 calories. And so it's not that like food volume is the only thing that matters or energy density is the only thing that matters, but they both definitely play a role in overall calorie intake. And so what does this mean for kind of high level weight management? Low fat diets aren't necessarily superior for weight loss today. Um, it's more of just understanding fat's role in increasing energy density, right? So it would be very hard to eat a low calorie diet if you consume almost entirely fat because, and we'll talk about this in a second, for every gram of food you eat, the satiety you get from that food is not great, right? So if you eat 1,500 calories in a bowl of nuts versus 1,500 calories in a bowl of carrots, it's like one of those is going to be substantially more filling, probably lead to you having orange skin from all the beta carotene. But the calorie intake is going to be different, the satiety is going to be different, etc. And so the kind of key takeaway is higher fat diets definitely make it easier to accidentally overconsume calories. So it's really important to be mindful and aware of energy density, especially when you're trying to lose weight or manage weight, right? It's very hard to control calorie intake if you're consuming a really high fat diet, right? This is why ketogenic diets often work in the very short term, but not in the long term. Because over time, after you've kind of adopted a new dietary pattern and lifestyle and all of those things, once you get used to it and it's not new or novel, your ability to control calorie intake when you're eating very energy dense foods from most of your choices becomes much more difficult. Okay. So the other thing we've often heard is that, hey, fat is actually one of the most satiating macronutrients. So if you eat a higher fat diet, you're going to feel full longer. Well, it turns out that this is really not the case. And so when you consume calories above like about 100 or 200 calories for like a small snack, it turns out that fats are probably the least satiating per calorie or per gram when you're eating a larger meal. Protein is definitely the highest. Carbohydrates actually the second, and fat is the least satiating. And this has been studied ad nauseum. And so this leads us to kind of the concept of fats and overfeeding. So when we kind of take a few of these ideas we've talked about, both in the carbohydrate chapter and this chapter, is we know that fats have higher energy density. They're probably easier to overeat from a calorie perspective. And if you're going to overconsume calories above like what your maintenance is from either fats or carbohydrates, what happens? And so it turns out that the body actually processes excess calories differently depending on whether they come from fats or carbohydrates. When you overfeed carbohydrates, especially in like a short-term acute setting, most of those excess carbohydrates are actually oxidized fairly quickly. We get an increase in energy expenditure to burn off those carbohydrates because it's harder to store them than it is excess fat. And so you get about, if you substantially overfeed carbohydrates, you get an increase of about 300 calories in a given day of energy expenditure. If you overfeed fat, you only get about 100 calories a day. I think this study was 95 calories a day. And so in studies where they've actually like overfed people either 1,000 extra calories from carbohydrates or 1,000 extra calories from fat, you store fat far more efficiently as body fat than carbohydrates. And this turns out to be true in almost every study that they've looked at this. So this whole idea of like, hey, if you overeat carbohydrates, it gets turned into body fat. Well, that's what happens with basically all excess calories over time, but it's far more efficient for your body to do it with fat than it is carbohydrates. And so this is why one of the reasons, like when I work with clients, especially if we're trying to do like, we're trying to add muscle tissue, we're in a bulk, we're kind of in, calorie maintenance or a slight surplus, we generally tend to lean on more of those calories coming from carbohydrates than fats. That feels counterintuitive to a lot of people. A lot of people have just kind of adopted this like, oh, carbohydrates turn to body fat. Well, it's actually the opposite. And so if you're trying to build muscle tissue and you have to be in a surplus, it's probably better to over-index on overshooting calories from carbohydrates than fats from like a pure body composition standpoint. Okay, so we will talk about this in a lot more detail in a later chapter, but I did want to give you guys kind of a short overview of what we know about fats and heart disease currently. Early on, saturated fats were strongly linked to heart disease based on early observational study. Recent evidence suggests that saturated fats themselves have a minimal direct effect on heart disease risk. Most of that risk actually comes from if you consume higher amounts of saturated fat, especially in the context of a calorie surplus, so you're gaining weight over time, it can skew your lipid profile such that your LDL is higher and your triglycerides are higher, so you have a higher overall cardiovascular risk. But it doesn't directly, the effect on like direct atherosclerosis, like if I eat saturated fat, it directly goes into my arteries, is relatively low risk, right? That effect is very small. However, it turns out that if you replace some of the saturated fat you consume with omega-3s or high-quality carbohydrates, which would be like whole food sources of carbohydrates, whole grains, fruits, vegetables, fiber, things like that, it may slightly reduce cardiovascular risk. And it turns out that a big part of how to interpret this data is that food context and specific types of saturated fat matter far more than blanket classifications. So for example, if you eat a diet that has about 10% of your calories from saturated fat, but it's all from the saturated fat found in highly processed red meat like pepperoni, sausage, etc., versus that 10% comes from like the saturated fat found in lean steak, some plant-based sources of saturated fat, like some coconut oil, some some grass-fed butter, things like that. Those are going to be very different, especially on your overall risk of cardiovascular disease. So it's important to understand that the context matters. And then the other thing is trans fats definitely show a clear and significant increased risk in cardiovascular disease. In fact, every 2% of daily calories from trans fats is linked to a 20 to 30% higher risk of cardiovascular disease. So that's a fairly meaningful increase in risk, right? I would say you're far better off to pay attention to trans fats than you are saturated fats if you can already consume trans fats in your diet. Okay, so what about the guidelines and recommendations? So these are, I'm going to just give you guys what the guidelines say currently, but I will give you a little bit extra context here too. So the recommendation for total fat intake is about 20 to 30% of daily calories. So that is a reasonable range. So for the average person on, let's say, a 2,000 calorie a day diet, that's 400 to 700 calories from fat. So that is what? Try to do the math here in my head. 35 to 75, 80 grams of fat a day is kind of the window. That's a pretty big range. That's about right. So saturated fat, try to keep it to a less than about 10% of total daily calories. This pretty much takes care of itself if you're eating a fairly wide variety diet and you're getting your protein sources from like chicken, fish, eggs, yogurt, some steak, things like that. This kind of takes care of itself. Oh yeah, see, there's the 45 to 80 grams a day. So omega 6s and omega 3s, these are the recommendations. I would focus primarily just on the omega 3s. I think you're going to get enough omega 6s. I really wouldn't worry about it. Another like ratio of omega 6 to omega 3 fatty acids, and that like modern day is way different from like prehistoric days or paleo days or whatever. Here's an interesting fact. This is a thing that has been said for years, but there's only like 1 or 2 papers that have been published about this in the nutrition science literature that I've been able to find, and I've looked. And it's a review paper from a guy who just gives his opinion. Like there's no hard data to support that. In fact, as we're reworking some of the certifications in the industry, we're actually starting to remove that entirely because there's just not a lot of data to support it. Like I haven't, if anybody's seen any new papers, please send them to me. Now, here's one of the more interesting things that's come up. I can't remember if it was what year it was, but the American Heart Association has actually removed the recommendations for an upper limit of cholesterol. And it turns out there's a few reasons for this. Your dietary intake of cholesterol doesn't really meaningfully impact your blood levels of cholesterol or your total body stores of cholesterol. Like you have, I'd have to go look at it, but I think you have like 50,000 milligrams of cholesterol in your body at a given time. And whether you consume 200 milligrams of cholesterol a day or 1,000 milligrams of cholesterol a day, it doesn't meaningfully impact your like total pool of cholesterol. Unless you're eating like a zero cholesterol diet, then you may see a decrease. And so it turns out that like the amount that you consume in a day, unless it's like that's the only thing you eat, doesn't really impact your blood lipids to a meaningful degree. And so even the AHA said, hey, there's really no recommendation on upper limit as long as that's not like the only thing you're consuming. So that's a meaningful change to dietary guidelines. So as I wrap up this summary, we can take some questions here and I'll hang out for a few minutes. All right, fats are the most energy-dense macronutrient. We store 50 to 100 times more energy in the body in fats than carbohydrates. The body contains many types of fats beyond triglycerides. There's really no true strict minimum daily fat requirement due to large internal stores. Like if you didn't consume any fats for a week, you probably wouldn't notice anything. But over a long period of time, like months, if you consumed a really low-fat diet, you probably would have, lower stores of fat-soluble vitamins. Your sex hormones may decrease. You may, cause some issues. Fat intake, really, when we talk about what our sources should be, try to focus on minimally processed sources and try to include about 1,000 milligrams of omega-3 a day. And that, again, like saturated fat's probably not something you should be super concerned with, but try to keep it to about 10% of calories per day or lower, somewhere in that range. So that's kind of the primary recommendations from the guidelines and kind of what we covered today. We've got a few questions. It said, you mentioned fat acts as a adipostat regulating hormones like leptin. Wouldn't having more leptin mean you should feel more in control of appetite, not less? Yes. So this is one of the issues. And we'll learn about this later in the course. But one of the things that happens in humans with obesity is we develop leptin resistance. So it turns out that as obesity increases or as BMI increases, for some reason, our leptin signaling starts to break down because in addition to insulin resistance, we also develop leptin resistance. And so even though like this is one of the reasons why the studies that have used leptin as like a anti-obesity medication haven't really worked very well, because they still have leptin resistance. And what's really weird is in those studies, when you lose weight, like if you have a high level of obesity, like leptin therapy is not working. If you lose a little bit of weight, the leptin resistance decreases, and then all of a sudden the recombinant leptin therapy actually starts to do its job again. And we will cover that in a later section of the course, because it's a really interesting piece. Totally random fact, grizzly bears have a different type of leptin signaling than humans. So it turns out like humans, as we become obese, leptin levels increase in like a linear fashion. So as you get a little bit more obese, it goes up, like in a linear fashion. Grizzly bears, their leptin stays flat as they continue to gain weight for hibernation until they hit like critical mass to hibernate, and then they get a huge spike of leptin, and that's kind of a big part of what sends them into hibernation. Sherry asked, does your body eventually end up feeling warmer once you're in maintenance, or will feeling cold always be present? So this relates to when you get low levels of body fat. Once you get back to maintenance, it shouldn't be as bad. But if you're a woman and you're running less than 20%, like you may end up feeling cold. Like I know I've maintained a relatively low body fat for quite a while. I'm actually thinking about changing that just because I am always cold. When I used to do a lot of other stuff and my body fat was like 5-6%, I was freezing all the time, and it's like one of those things that's really not enjoyable. And you know, we're not really supposed to be running around with that low of a body fat percentage. All right, any other questions? Cynthia said, how does the body decide where to store each type of fat? For example, does it get stored as subcutaneous fat first and as visceral? Also, when losing weight, does one come off first before the other? So this comes down to a lot of different things. So one of them is there's a little bit of an order of like most people generally store subcutaneous and then visceral. Generally, we lose from both at the same time is kind of generally how it occurs. Some people lose sub-Q a little bit before they lose visceral. Some people lose visceral before they lose sub-Q. We don't really know exactly why it is. I think part of it has to do with your hormone profile. That's not just like, you know, testosterone, estrogen, cortisol. It's also like your insulin signaling, your leptin, all of those things I think go into play. But generally it's you add sub-Q, then visceral, and when you lose weight, it comes out a little bit from both. There's a lot of papers that will look at visceral versus subcutaneous fat loss amongst weight loss, and you can actually go find those, and I'll see if I can pull some and post them in the group later. All right. Well, again, thank you guys for your patience as we got started a little bit late. I'm on dad duty because the nanny is off today. But I will get this. YouTube takes about 24 hours to get the video processed, so I can just cut the beginning out and upload it. So this should be available late tomorrow, early Friday. But again, thank you guys so much for your time. I will see you guys in 2 weeks, but I'm going to answer one more question first. When a person starts keto or high-fat diets, what is the cause for the bowels to become more often? So basically, a big part of it is your digestive tract requires a lot of the lipases and the pancreatic enzymes to emulsify that fat so you can absorb it. When you go from a low fat diet to a high fat diet, your body isn't used to that yet. So most of those fats don't get digested. So they actually end up just going through your system. So you end up basically just like having what we call steatorrhea, which is just diarrhea from consuming too much fat. Like if you were to go drink a gallon of olive oil, don't recommend this. Do not do that. But that's what would happen, right? It's basically the same thing that happens when people used to take, I think it was Orlistat, like the fat absorption blocker. It's the same thing. It's just your body isn't producing enough enzymes to emulsify that fat and absorb it. So, awesome. Thank you guys so much. I will see you guys in 2 weeks. Have a happy Thanksgiving. It is Black Friday for us next week. Actually, not next week, in 48 hours from now. So I will see you guys later. Thank you very much. Adios.